Okay, I think we're good. It doesn't seem like it's gonna keep buffering. It seems good. I had to switch restream servers. It might be time to find a new service for that at some point. Because so many issues just from restream. My internet's pretty much always stable here, at least at the new facility. Anyways, get back to this. So what I wanted to do here was I wanted to find the really long runs. We have this one right here, actually. This is our best one ever. So actually, right, this doesn't do anything for over 1 billion steps. This doesn't do anything for over 1 billion steps. If I were to set up a 10 billion step run, it's just not going to do anything, right? It's going to take forever. Tricky. Very tricky. If we do a 2.5 billion step run and hope that the results generalize a bit better now, huh? Try that. Then that one actually can get us like a reasonable-ish number of experiments. Okay. We're just going to delete this. $2.5 billion steps. Oh, you know what? I don't think we did the mini batch size correctly at all here. The 16384 is what we've been using. Okay, we're gonna try this. I should have it auto-gen tags. Okay. So we have this going. Let's now go back to the meta experiments. Go right here. Where are our results? I guess we have to redo our dashboard for this. Mildly annoying. Pepper, it should be good now, right? Good. And we will be back to your daily scheduled experimental analysis. I think that the way we're going to do this, we're just going to grab like some random run. So for some reason, like these are just not showing up anywhere. I see it right here, train/Atom Beta 1, right? Hang on. So it has all these train/whatevers. Oh, it probably doesn't have score, right? Yeah, that's it. It just didn't define. Alright, that's not on me. I'll just make him a dashboard real quick, now that I know what it is. So what we want to do here is we want to grab all the parameters that can have some sensitivity to hyperparams, which is pretty much everything that is worth sweeping, right? this is atom beta 1. And then this is let me just make sure this is not different for heart.gained. Uh, 2.7. It is actually slightly different. But luckily, this is the lower of the two metrics, so we're not overinflating. Coefficient. Entropy. Entropy is definitely worth doing. Gamma lambda, obviously. GAE params are among the most sensitive. You can see right there the fall off. We should probably do the max gradient norm. Just in case. I've seen it like sometimes. It can matter. Oh, hang on. This is. Let me just go tell. I gotta go tell somebody something. Okay. I was coerced into doing some overhead rock presses while I was there. I'm time to squat while he ain't here. I have Pepper, there's actually, you'll probably see it in the background. I have a freight delivery today with a pretty awesome new piece of equipment. So I'm saving leg strength for that. You will see. It's a pretty cool piece. I've wanted one of them for a long time. It's probably not something that you've ever seen. It's a very specific piece of equipment. We're also ordering more hardware for Puffer today. No, the 5090s actually, they're worse perf per dollar. We're specifically and intentionally getting a couple of V1 tiny boxes. They had a couple of them left because they have 6 4090s instead of 5 5090s, which is better. And also it's a bit cheaper as well. We do want to include alpha here. So these are the prioritized replay coefficients. Whether these matter or not depends strongly on the environment from what I've seen. I mean, that's something, right? This actually, there is a stable range in here. We also need the value function coefficients. That's a very clear correlation. Flip coefficient doesn't seem to matter as much. That's kind of interesting, right? It really doesn't matter where you clip it, but you need to have a bit weird, right? D-trace, and these are not swept. Okay, cool. So those are all the params. Let's just take a little bit of a look at these. See if there's anything wrong or unexpected here. Okay, so atom beta 1. This should have a stable range. It seems like we get good results in a decent range over here. Okay. beta 2. This one is wrong. This is supposed to be atom beta 2 last. There we go. This one does want to be quite close to 1. But it's like... Hang on, is there a way... Can I do log? No, because it doesn't know what a logit is. It needs logit scale, man. Flip coefficient, actually, right here. Flip coefficient, there's a little bit of advantage to be gained here by actually tuning this, right? And all these around 0.18. Too high entropy, bad. Gamma obviously has its region here. Actually, very high gamma seems to be the best for this, which is interesting. Lambda has a stable region. 8.8. Learning rate has a stable region. Grad norm, large, stable region, doesn't matter a ton. Prioritize replay alpha. Actually, there is a pretty nice correlation in here, right? The beta. Beta just wants to be minimized, it looks like. There's an interpretation of that. I'll have to look at the math. Value function coefficient needs to be bumped way up. But clip coefficient doesn't matter. Okay, cool. I think we can actually export this to a report. Oh, and I can just send somebody this link. Perfect. Bit of this one. So this should be pretty well soda for them, based on their experiments. This is fast soda as well. What is this run right here, I want to know? Right here. What's the uptime on this? Less than 10 minutes. Just go find like some of the best. Not too much in atom params. Clip coefficient. Surprisingly high gamma. Lambda's pretty stable. 003. Huh. Okay, the alpha coefficient does matter. There we go. They should be very happy with this. They should be very, very happy with this indeed. Cool. They should be very, very happy with these results. This is, I believe this is soda for them in like a tiny, tiny fraction of the amount of training. And this is like comes with a ton of insights. Yeah, they should be very, very happy with this. It's good. Good time to mention that all of our stuff is free and open source, but we do stuff like this paid for people in industry. So if you do RL in industry or know some folks who do and they're having a hard time of it, we make RL much, much faster and much, much easier. Like this set of experiments in particular, this is not something that you could run anything remotely close to in any other library or system or whatever. This is directly from our latest release, and these results are pretty much unthinkable, like even a few months ago. Very strong results. You know, and because these are very strong results, I'm starting to wonder if we have issues with neural MMO3. I bet you there are some data issues with neural MMO3. We should go look for those at some point. But I think in the meantime, I think we come up with a plan for the rest of the day. I've got half an hour now to work on a few things, and then breakfast. And then I will be free for the rest of the day, except for whenever the new equipment gets here. I got to take delivery of that, which I'll probably just leave the stream on and have that in the background. We'll see. It'll be fun. Depends how long it takes. Okay, let's take a look at our latest release. Oh, and actually, let me send these params over to Aaron so that he can, because he should be able to do some work on this, just so he can take it from here. So Aaron will do that. Does PufferLib support continuous M's like Majoko, DeepMind Control Suite, or Mayo? Yes. We have continuous control support. We've done paid robotics work for clients before, specifically in animation gen with Isaac Jim. We don't tend to use a ton of continuous control stuff in our benchmarking just because our M's are way faster. But it is very easy to bind any existing thing to PufferLib. And we can help with that on the open source side for free, or if you want a little bit more insight and you do stuff in a company context, then we can do that under contract. But like I say, all our stuff is free and open source, so you're free to just use it. The contracts are just if you want the types of results you see here that we get for all these other ends. But we've kind of done enough fundamental stuff for a little bit here. I think that I really want this file to be, which is our main train file, I want this to be virtually ready to go today. Let me think how much other stuff there will be. Like, what is on the total to-do list still before release? Like, the meta results actually make me way more confident in releasing this stuff. Like, the quality of what the results are. But there's still, like, some usability things I want to have fixed. Just, like... So this is all that we have in PufferLib. I don't think we need to mess with the emulation file very much this release. Models are pretty fine. There are a few very small tweaks. PufferLib/PufferLib just has utils. There are a few things to clean up in PyTorch. We really don't have that much left to refactor outside of the main train demo. Flip range for continuous policies. Make it easier to not forget initialize num agents. Yeah, there are a few like quality of life things, I think mainly in the new env API. But those are all like pretty quick and straightforward. So really like final checklist. So we have like welcome YouTube folks. Good number of people here on 9:30 on a Thursday, or I guess it's Friday. Whoops. My hope for today is that we get like all the small stuff to a good spot, because tomorrow is my longer work day, and ideally tomorrow we can start running all of the like experiments on all the different M's and baselines and really start locking down stuff for the release. So I guess the big things on the checklist, RIST, it's final cleanup. So it's like major is the clean PufferL, minor QOL in rest of library. We need working baselines on puffer ends plus a few externals. Probably like Atari. And if you have suggestions for what we should really include in our benchmarks here, guys, if anybody wants like a specific env included, if we already have it and it's fast, I can just run it. If we don't already have a binding for it, and you want to help us add one real quick and then we can run stuff on it, that's also cool. So if you're still here and you want to add, like, we already have Majoko binds, and like, I think we have an old DMC thing. So if you want to help us get some stuff running on that, we can even get those into the next release here. Welcome, Arga. Okay, so next we need like high quality sweeps for major M's. So NMMO3, GPU drive, impulse, force, power climb. See? Minor M's should work on 1 H param set. Hey bro, can you tell me how to fix Ubuntu sound problems? This is not general tech support channel, my guy. This is RL. And I don't think anybody can tell you how to fix your janky Linux setup. I still have jank things with my setups all the time. I've been using them since I was, I don't know, 14. What is the actual speed up over using the gym M's for Majoko, for example? So you are always going to be bottlenecked by environment speed. But typically, if you use gym vectorization or anything, you're not going to get anywhere near close to core speed times number of cores. There's a lot of overhead. PufferLib has virtually zero overhead. So you're going to get very, very close to linear speed up over number of cores. On top of that, our trainer is very, very low overhead as well. And our trainer is just better. Like, we're not using exactly PPO anymore. We have substantial improvements on top of PPO. We have our own advantage function. We have filtering. We've got prioritized replay that's still on policy. We have a lot of new things. Plus, we have the best hyperparam sweep stuff out there as well. So typically the workflow in Puffer is like, get your thing set up, tune it a little, make sure it's fast, run 100 or 200 experiments, and boom, you have the thing automatically solved. It's like actually remarkably easy to get stuff working on new M's like that. We have had people do stuff with Majoko that worked pretty well in the past. We just haven't like done it lately on our main benchmarks. But yeah, it would be pretty easy to get that stuff set up and working here. What if I want to use my own algorithm? I'd need to implement it into Puffer. Technically, yes. And actually, let me answer both of those questions at the same time from Browser as well. So here's the thing. If you like are thinking about Puffer compared to like SB3 or RLlib or one of those, it's not. It's way lighter weight. Let me show you. This is our entire training code. It's one like 1,000-line file. This has everything. So this isn't the type of thing where you're going to have to go dig through a bunch of things. Like, if you want to implement your own algorithm, you can pretty much just do it cleanRL style in this file. And if you use, like, the way that we have our data set up in here, just in this file, you'll maintain all of our speed optimizations as well. Plus, this comes with, like, profiling to make it really easy to optimize, too. If you just want a hyperparam optimization, it's in this file. This is it. Like, I don't know, the only real dependency here is Pyro. I think the SciPy stats one's even outdated. Yeah, this is dated. There. Only dependency is Pyro, which we use for Gaussian processes. You can just take this file and use it. Now, if you're doing RL anyways, I'd suggest checking out our trainer because it's really fast, and it works really well with this. But yeah, you can totally just use this. So Browser, to answer your question at the same time, there you go, right? Like, it's not some massive framework. It's really, really fast, but it's also like a couple of files. And we also have, I mean, I stream dev constantly, so it's easy to get help here. And we also have a nice community on Discord. Speaking of which, did we hit 2K? I know that this was rounded. Did we hit 2K? We hit 2K. That's awesome. 2,000 stars on Puffer. I'm so happy with that. Holy. That's been a goal for a while. And it's really nice to have that. You know, the thing that just screwed with me my entire PhD. Let me show you something. So this is what I worked on my entire PhD. Got 531 stars, right? And this is with me like, you know, working my ass off running competitions, trying to like do all sorts of stuff to like, you know, foster RL in the community, like make stuff easy, get multi-agent stuff happening. Like I put like my own like unpaid time and a ton of money into these competitions as well. And it did okay, but like it never really took off massively. And then the thing that just always screwed with me is that the initial release while I was at OpenAI, just based on the OpenAI publicity, got like this just from like the old unmaintained 1.0 repo. So it's pretty cool now it's been about 1 year since I graduated to have 2K on an RL repo, which for RL, that's pretty dang big. That's bigger than a lot of the other libraries that have been around for longer. And also to know that we have the fastest code, the simplest code, right? We have the best results on a ton of different benchmarks. Now we're going to have 15 plus ultra high perf custom environments for research. We've made some of our own algorithmic improvements. Like this is going very well. So here's the next release. Might actually be the 2000th. Thank you very much for that. I think you were because it was 1999 last night. So thank you very much. Packaging. Anything else that should go on this checklist? We got to get the final cleanup done. Thanks, Pepper. We need to get some baselines on all our M's, plus really high quality sweeps on the important M's. Replied in your post. Yeah, my DMs are open, man. So if it's public stuff, Discord, whatever, if you have like business inquiries or whatever, yeah, my DMs are always open. Did I miss anything on the final checklist here? I just want to make sure I have everything. I guess DDP. So we need like tuned DDP plus compile plus AMP perf check. I'm trying to think if there's anything else we need to do for release. Because I've got like another 10-ish minutes now, and I want to have the full picture. Because basically what I want to do is I want to set myself up so for the whole rest of today, and then tomorrow I don't have to like keep going back to this. I want to just be able to go, right? I want to just be able to like do the dev, oops, and just hammer this all out. Docs. You forgot docs. New docs. Updated. Is that everything? This is the biggest one here. And packaging. These are the two hardest ones. Is like getting the code in a state I'm happy with, because I'm picky. And then packaging. I'm pretty confident we can get good baselines on everything. This we basically already did. These are easy experiments. This is just like busy work. I guess I do have to make sure rest of M's are ported. I guess. Okay, so if I do this, then what's the release gonna look like? Oh yeah, the blog, obviously. So this is gonna be protein, which is our new hyperparam sweep algorithm. This is gonna cover puffer advantage plus filtering, which is like our algo side stuff. Oh. Yeah, I was wondering why it got so loud in the background. Turns out that rain on a metal warehouse roof is pretty loud. Hopefully the noise filter catches most of it. Protein, puffer advantage filtering, C API. What other stuff should I put in the release that would be hype? The new M's, obviously. Maybe like a speed run. Something like that. I mean, the big thing about this release. Yeah, those are all the topics I want to cover, I think, in there. That's good. I think this is about enough for release. If we do all this. So let me just bullet this out so I know what I'm doing today, and then I'm going for breakfast in a few, and then I'll be back and I'm going to start with this whole cleanup, I think. So this is going to be like Neptune, Wand B, artifact, load save, general, line by line, cleanup, mod, eliminate. Is that everything? Yeah, I'm warning. Clip range for continuous pulse. Oh yeah, continuous. Well, I don't know if you actually want to have continuous. Maybe we'll do that. And that should be everything. Okay. Arga, we don't currently do internships. This is all like open source stuff. We do a small amount of paid work for clients in RL, but then the people I put on those are either PhD students I've worked with previously and I know I work well with, or top contributors to PufferLib who I know can get the work done. We don't do like random like fixed time position hires, intern or full time either. And that's just mainly because of the way the company is run. Like the income for the company is from clients. We don't have funding or other stuff, so it's like we hire people to do things for clients, not like general full time for Puffer. Was there anything else I wanted to do? Oh yeah, I wanted to check whether you need multiple data points, right? Well, I can put that in here. Do you need multiple sweep points per run? All right, that should be everything here. Hey, Spencer. Yeah, let me take a quick look at your sweep, though. I'm going to have to go any second for breakfast. You know, thanks for your interest, Arga, here. It's just the way that Puffer works, we're very heavily trying to bootstrap this. So we can't just, like, randomly be hiring interns when there's not, like, income coming from those interns for clients specifically. So I don't like to advertise to people like, hey, if you come do a bunch of free work, maybe there's a position for you, because that's kind of jank. It's more so just like people contribute who want to learn and contribute, and then, you know, if people get good enough, we can pull people from community into gigs when they make sense, but there are no guarantees on that. Let's see your sweep, Spencer. Please link sweep. And actually, I'll say for the people watching, because I got to go in a second, I will be back after breakfast for the whole rest of the day. So all my stuff here is on puffer.ai. If you want to help me out for free, just start the repo. If you want to get involved with open source dev, just join the Discord. You don't need an RL background, you just need a programming background. Most of our top contributors came in with no RL background whatsoever. You can also follow me on X for more RL content. Okay, here's the sweep. Spencer, just link. Oh, you are in the chat. Cool. Yo. You're muted, but how's it going, Spencer?
Yo. All right, so
What's
score
this
is a little
30?
funky, but completion rate is good.
Okay.
So the score technically now should be clean executions before of a clean completion rate before hitting anything. But when testing out the policy, it actually looks pretty decent. And I think the reason why the score is coming down low on that is due to the respawn stuff.
Okay. So I mean, it's good now we're just down to like a little bit of env jank on this for the most part. And yeah, I think you'll have this in the new env to play around with. And we can just go back and forth on stuff for these. We will have to figure out the speed at some point, but I think we can do that after It's probably just going to be a matter of cutting out redundant obs.
Yeah, I think that's probably gonna be most of it. So I was thinking what I'll do is I was gonna change how the collisions are recognized,
Hmm.
such that collisions are only recognized if it is prior to you reaching your first goal. And like if you run into a car that has already reached its goal on their second life, then it doesn't count as a collision.
Are you still going to get negative reward though?
Well, that's the part I was gonna take out.
Well, they need to still get a negative reward for colliding if you want them to not learn to just go through each other. Because if they only get a penalty for colliding on the first time, then like it's questionable whether they actually learn to stop colliding. Like they could actually
Well,
learn after I get the goal once or whatever, I can collide as much as I want.
what if I add an observation that is like have has that agent reached its goal and you can
Mm,
see it? Because arguably you should be able to phase through another car in the second life.
I mean, the main thing you're learning, like not colliding with stationary walls, should be learnable very easily. The main thing you are learning is avoiding collision. We need to think of a good way to handle this. That's like, I wonder if the spawn immunity just covers it, right?
Well, that's what I was offering was just like collisions don't count if
But it would be
someone has
like it
just
doesn't
spawned.
count for a few, like
I mean, you could do it for like 10 time steps or whatever, or like
it would have
something
to be for like some fixed number of time steps. So we'd have to like look like how long roughly these time steps are. Because the idea is like if a car spawns right in front of you and you're already going that direction, you should be able to go through it.
correct. Off-road rate is pretty much solved at this point. It's 0.6%.
Okay, good.
So it's entirely collision rate because completion rate is getting up to 95% now. And then car collision still at like 20%, of which I
Probably a
think
bunch
that's
of it
really
is, yeah.
it's just the respawn things.
Okay, cool.
And then so yeah, I mean some degree of spawn immunity. And then second thing to look at is uh what was I gonna say? Oh, confirming from the actual original GPU drive environment that the cars that they're spawning are the same cars that I'm spawning in the agents that are considering to be agents.
Hmm.
Because I can't do that really on my computer.
Yeah, no, we'll make sure of that. Don't worry. I'll have to set it up locally, but I'll do that. Okay.
Okay, but so for now, do you think just doing try spawn immunity and see how it goes? Um,
Yeah, do like a few frame spawn immunity and see how that goes. And rerun sweep, see if we get like close to 1.
by the way, this sweep was with annealing on, and it's solved in like 70 million. Do you want me to go a non-annealing sweep?
If you're solving, it doesn't matter. The kneeling only matters if a kneeling off only matters for stuff like neural MMO where you're doing a very short sweep to try to predict a very long run.
Hmm. Okay, all right, sounds good.
Cool. Okay. The plan for me for today is going to be to like clean up pretty much the whole rest of Puffer. We got some amazing results overnight on meta, so like it's in a very good spot. I just there's like a whole bunch of stuff I want to clean up so we have the stable final version of the transcript, and then you can
Mm-hmm.
see